So our last lecture was concerned that how can we find the type of astigmatism with the help of the optical cross. Either it is simple myopic, simple hyperopic, either it is compound myopic or compound hyperopic, or it is mixed astigmatism. Or we also learn to rule out that either this this astigmatism is actually with the rule astigmatism or it's against the rule astigmatism. And in the last lecture, the confusion was some students confused about this scale. As I mentioned the rule of thumb in the last lecture, and as I mentioned that if hypermetropia is increasing, the power of the power is decreasing, right, in the last lecture. And when myopia is increasing, the power is actually increasing, right? This is a thumb of the rule, and in this video I'm going to explain that rule of thumb, right? So in the last lecture I draw a scale like this. So we have a zero value in this scale, right? And in this direction you can see the minus values, and in this direction you can see the plus values as well, right? So this is 0, plus 1, plus 2 hypermetropia, plus 3 hypermetropia, hypermetropia plus 4, and hypermetropia and plus 5, and so on, right? And in this direction, this is myopia of 1, myopia of 2, myopia of 3, 4 myopia, and 5 myopia, and so on, right? So we have a scale which is starting from 0. In this direction we have plus values, hyperopic values, and in that direction we have myopic values or minus values, right? So now let's learn about this scale. Let's learn about the rule of thumb. What does it mean when I said in the last lecture that when hypermetropia is increasing, power is decreasing? What does it mean? What does it mean when I say when myopia is increasing, the power is increasing as well, right? So I'm going to explain this confusion here in this lecture, right? So remember that if this 0 is actually considering the normal cornea or the normal power of the eyeball. Some author says the total power of the eyeball is 60, some says 58.8 diopters. So in this lecture we are taking 60 diopters as standard total normal power of the eyeball, for example, right? So 60s are, so here 0 means if power of the eyeball is 0, 0 means 60 diopters, right? It means when total power of the eyeball, when total power of the cornea is normal, is optimum, so it means cornea is symmetrical, cornea is prolate, it's not very steeper, it's not very flatter, it's normal, it carries the symmetry, right? Cornea is symmetrical at its optimum power, which is 60, for example, right? So here 0 means 60 and cornea is totally symmetrical like this. Cornea is fine, it's not very flatter, it's not very steeper, because we have optimum power, we have normal power. But now I'm going to explain that what does it mean when I say when hyperopia is increasing, power will be decreasing, right? What does it mean? It means when cornea has 60 diopters normal power, the cornea is symmetrical. When the patient carries hypermetropia, but what if patient has hypermetropia, right? And when patient has hypermetropia of plus 1, plus 2, 3, 4, 5, or so on, then what will happen? So when hypermetropia, so first we will discuss about what is actually hypermetropia. Hypermetropia, this is a typical definition that light rays are coming and focusing behind the retina. This is called hypermetropia. Okay, fine. But the real actual definition of the hypermetropia in a clinical point of view is that the decrease in the plus power of the eyeball is called hypermetropia. When power is decreasing, because eyeball carries only plus power, when plus power is decreasing, it means it's hypermetropia. When it is increasing from the normal, it is myopia. Very simple. So in hypermetropia, the power of the eyeball, the 60, the total power of the eyeball is decreasing. So plus 1 hypermetropia means that we have now total power is 59, plus 2 mean 58, 3 mean 57, and so on, right? So it means hypermetropia is actually decreasing the plus power. So you know very well, you are a quite smart optometrist, you know very well that when hypermetropia is decreasing, when hypermetropia is increasing, right, the total power of the eyeball is actually decreasing. And when power of the eyeball is decreasing, the flatness of the cornea will increase. Cornea will be more and more flatter. Decreasing of the power, flatter will be the cornea, right? If plus power is decreasing, cornea will be more flatter. If hypermetropia is of +1, cornea is flatter. +2, more flatter. +3, more flatter. +4, 5, more and more flatter, right? So when, let me tell you that now we have concluded that, as I said, when hypermetropia is increasing, the power will be decreasing. So when I say power will be decreasing, it means the cornea is going to more and more flatter, because in this lecture we are going to learn about the type of astigmatism. Astigmatism has two principal meridians, right? So we have to see that either this vertical meridian is more steeper or flatter, or the horizontal is more steeper or flatter. So how would we know that which meridian is flatter, right? In this with the help of this scale, right? If +1, +1 means +1 hypermetropia. Hypermetropia means plus power is decreasing. Plus power decreasing makes cornea more flatter. +2, more flatter. 3, 4, 5, more and more flatter, right? So that's why I said when hypermetropia is increasing, power will be decreasing, because in hypermetropia plus power always decrease. So when plus power decreasing, cornea will be more flatter, right? Now, what is the definition of myopia? Myopia is actually, it's a typical definition. Literally, I hate this. When the light rays are coming and focusing here and here and here. Okay, fine, right. But what about the clinical point of view? When the light rays are coming, focusing in front of the retina, that is called myopia. Okay, fine. But what about the power? When the plus power, the total optimum power is 60 diopters, and when power will be increasing from the 60, it is going to 61, 62, 3, 4, 5, 6, right? So it is carrying more and more myopia, right? So 60 diopters, normal. Cornea is no more flatter, no more steeper at optimum, at normal power. But if your patient has -1 myopia, myopia of -2, myopia of -3, 4 and 5, actually the power of the eyeball is increasing, right? It is going from 60 to 61, 62, 63, 64, 65, right? So power is actually increasing. So when power plus power of the eyeball is increasing, that refractive error is called myopia, right? And you know very well that cornea was totally fine, cornea was totally symmetrical, prolate at normal optimum power. But when myopia of -1 is there, cornea will be more steeper. Remember, whenever the plus power in the eyeball is increasing, cornea will be more steeper. So at -1, cornea will be more steeper. At 62, cornea will be more steeper. 3, 4 and 5, cornea will be more and more steeper, right? So in the last lecture, as I told you that when myopia is increasing, the power is increasing, right? It's quite simple. When myopia will be increasing, actually the plus power of the eyeball, the total power of the eyeball is actually increasing. So when the total power or plus power is increasing from the normal, cornea will be more and more flatter. I hope this is clear. So now let's take a simple one example. Suppose you have +3 with -1 cylinder at 180 degree. So how would you know that either this is simple hyperopic, simple myopic, compound hyperopic, compound myopic, or mixed astigmatism, or it is with the rule or against the rule astigmatism? So we will draw optical cross here, like the last lecture. So we have spherical +3. If your value is spherical, it means around the 360 the power is the same. So we have only two principal meridians. So we have +3 at vertical meridian, and we have +3 at horizontal meridian as well, because sphere means all around, power is the same. But we have cylinder is always at specific meridian. So our cylinder is at 180 axis. So axis, the meridian of the axis is 180 degree. And remember, if you remember, if you recall the last lecture, that power meridian and axis meridian are 90 apart. If power meridian is at 90 degree, axis will be at 180 degree. If power at 180 degree, axis will be at 90 degree. They are 90 apart from each other, right? So axes are at 180 degree, power will be at simple 90 degree. So this is 90 meridian, we will write -1 here, right? So +3 and -1, +3 and -1, the value will be very simple, +2, and we have +3 as such, the spherical. So we have +2 at one meridian and +3 at another meridian. Both the values are in plus form. So it is compound hyperopic astigmatism because both the values are in plus form. So light rays, 2-point foci are focusing behind the retina but at different locations. So this is compound hyperopic astigmatism. So this is compound hyperopic astigmatism, and now we are going to rule out that either it is with the rule astigmatism or against the rule astigmatism, right? So we have +2 and we have +3. As we have known in the rule of thumb that in +1, +2, +3, as the hypermetropia is increasing, the power is actually decreasing, right? So what does it mean when I say power is decreasing? It means that cornea going to more and more flatter. So at +3, cornea is more flatter, it is not steeper. So it means that this is because at 180 degree we have +3, and +3 means cornea is more flatter. So cornea is flatter at 180 degree. At vertical meridian we have power of +2. +2 means cornea is comparatively more steeper than +3 because it is near to the 0, right? So +2 carries more steeper. If I compare that +3 hypermetropia and we have +2 hypermetropia, so in both of these hypermetropias, cornea is flatter in +3 or +2. In +3 cornea is more flatter, but comparatively in +2 cornea is steeper. So it means +2 is at 90 degree, so this is more steeper. Here it is +3 because +3 is more hypermetropia. The more the hypermetropia, the flatter will be the cornea, right? So this 180 meridian or horizontal meridian is flatter as compared to +2, and we have +2 at 90 meridian or vertical meridian. So if we compare +2 with +3, +2 is more steeper than +3. So this meridian, 90 meridian, is more steeper. So if remember the definition of the with the rule astigmatism, if 90 meridian or vertical meridian is more steeper than the horizontal meridian, that is called with the rule astigmatism. So this is compound hyperopic astigmatism and with the rule astigmatism. I hope this rule of thumb and this scale is clear. We'll see you on the next videos.